In this problem, we are given a right triangle with hypotenuse 45 centimeter and variable lengths x and y centimeter. And we are also given that x is increasing at a rate of 2 centimeter per minute. And we have to determine the rate of change of y at a point when x equal to 4 centimeter. So basically, we have to find the dy over dt. So that is the change in y with respect to time. So I have first drawn the picture of a right triangle, which is best way of visualizing the situation with the two legs as x and y and the hypotenuse 45 centimeter. So let's apply the Pythagoras theorem here. We know that Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse and A and B are the two legs of the right triangle. So we can apply this Pythagorean theorem over here. So when we do that, we get x squared plus y squared equal to 45. Now since this involves varying, that is both x and y are changing at a certain point of time, we can find their derivatives. We are going to do the implicit derivative. So we will do the implicit derivative as it is. And this implies I'm going to write down in mathematical notation, that is derivative of x squared plus y squared with respect to time, and also on the right side, that is derivative of 45 with respect to time. Now we can use the sum rule to find the derivative of each of the terms. So this can be written as d by dt of x squared plus d by dt of y squared equals derivative of a constant, that is 45, is 0. So I put 0 over here. Now we have to apply the power rule as well as the chain rule to find the derivative of x squared with respect to time. So when I apply the power rule, which basically says that if you have to find the derivative of x raised to the power of n, this is actually equivalent to n times of x raised to the power of n minus 1. So basically you just have to put the power in front and raise x to the power of n minus 1. So when I do that derivative of x squared, I have this power 2. So I put the power 2 in front and raise x raised to the power of 2 minus 1. Because the power is 2, so we have to reduce it by 1. And when we do that, 2 minus 1 is 1. So it's basically x raised to the power of 1, or we can just write down this as 2x. And then we have to apply the chain rule. So when we apply the chain rule to find the derivative of x with respect to time, so this is equivalent to dx over dt. Now let's apply the same thing to this second term. So first we apply the power rule, so we get 2 times of y, and then we have to use the chain rule and derivative, find the derivative of only the y, so which will give us dy over dt equals 0. We will utilize the given conditions to substitute into this equation. So we are given that we at x equal to 4 centimeter, dx over dt is 2 centimeter per minute. So we can utilize this as well as this. Let's substitute into this. So I'm going to replace x equal to 4. Let me copy it here. And dx over dt equals 2. I substitute into this. So when I do that, I get 2 times of x is 4 and dx over dt is 2 plus 2 times of y. I don't have the y information yet. We will find it. So then we have to find out dy over dt. So let's see how to find this y. We can utilize once again we can utilize the Pythagorean theorem, because it is given that the hypotenuse is 45. So I'm going to find the y when x equal to 4. So for that I use the Pythagorean theorem, that is x squared plus y squared equals 45 squared. I plug in x equal to 4 here, so this gives me 4 squared plus y squared equals 45 squared, and y squared equal to, we can simplify this. 45 square is 2025 minus 4 square is 16. So this gives 2009. Therefore, y is the square root of 2009. Since y squared equal to 2009, y equal to square root of 2009. And if we find this using the calculator, approximately we get 44.822. So this is the corresponding value of y when x equal to 4 centimeter. We can substitute this into this equation. So I can replace this is y 2 times of 44.822. I'm replacing it here. 44.8. I don't have space. Let me just move it a little bit. 822. Again, I can move it back over here. So let's simplify this. We have now in this equation we only have only one unknown, that is dy over dt. That's what we are going to find. So let's simplify this. This is 2 times 4 is 8. 8 times 2 is 16. Plus we can plug this into the calculator. It is 44.822 times of 2 gives 89.644 times of dy by dt equals 0. So let's subtract negatives, that is subtract 16 and then divide by 89.644. So we will get dy by dt by itself, that is negative 16 by 89.644. So when we plug this into the calculator, we get the value as negative 0.178. This is being rounded to 3 decimal places. So this is the rate of change of y. We have one information, that is the value of negative. When we have the sign as negative, this means y is decreasing. So this answers this question. dy by dt, or the change of y with respect to time when x is increasing, is negative 0.178.